today what we're going to be working on are parallel lines and angles. Probably one of my more favorite units to cover in Math 2. It should be a boost your average kind of unit. What you see is what you get kind of sort of deal, or I like to tell people just go with your gut. That'll make more sense a little bit later. It's going to be pretty short. We're going to cover 2 lessons. Lesson 1 is just going to be getting us back familiar with the different notation and syntax of things. Also talking about a handful of the big angles that you're going to see in this unit, such as complementary angles and supplementary angles, as well as adjacent and vertical. Today what I want to focus on, again, just brief refresher of what does lines look like, rays, points, angles, etc., and also get through complementary and supplementary angles. So without wasting any time, we're going to go over point or different vocabulary words you'll see in this unit, what their symbols look like and their definitions. Honestly, guys, if you can remember symbols and what it's called, and also just a little bit of your definition, you'll be just fine. All right, so a point looks like a dot. All right, and very simple. It is just a single place on a coordinate plane, or just a regular plane. A line looks like what we would normally think of, just don't forget you have an arrow at the beginning and at the end. Again, also a line has to have at least 2 points. Okay, it's a never-ending segment with 2 points. With at least 2 points. Okay, so a segment, essentially think of a segment as a line, again, with a starting point and a stopping point. Okay, so a segment has a starting and ending point. A ray starts and keeps on going. Okay, so it has a starting point with no end. An angle, if you want to think of this and create your own definition, you have a ray on the left, you have a ray on the right, they meet at this particular point called a vertex. So an angle is just 2 rays with a common vertex. Again, out of everything I've listed so far, vertex, that's probably the most important. Congruent looks like an equal sign with a squiggle up top. It just means the same or equal. Okay, for our sacred terms, this isn't mathematically correct, but don't worry about it. Again, congruent, same, or equal. Parallel looks like train tracks, okay, or the outside of a capital H. Okay, parallel lines, y'all know what these are. Y'all looked at them a lot in Math 1, or lines that never touch. Perpendicular, you also looked at these when you were doing, this kind of should have been at the tail end of slope stuff, writing equations of a line that's perpendicular to a given line. All right, so perpendicular, for what we need to know in Math 2, it just means 90-degree intersection. Some of y'all would even say, ooh, Mr. Hill, a right angle. That's absolutely correct. All right, and again, a right angle looks ideally a perpendicular line or symbol symbolically, it's just missing the left hand side. And again, right angle just means 90 degrees. Alright, not worried about this down here at the bottom. Moving right on to page 2. Not going to go through all of these, maybe do like one from each line if you have questions. What I want you to do is try to do them on your own. If you're confused, email me and I'll get back to you and we'll talk about it. I'll make another video for you. So, A is array. Again, why is it array? Because it has a starting point and it has an arrow at the end so it doesn't ever end. Y'all take your time right now and see what you think B is. B winds up being a line. Again, the giveaway for a line, it has 2 arrows on it. One at the top, one at the bottom, or bottom, top, however you want to read it. Alright. Y'all always ask, where can you see this stuff in the real world? Well, here you go. Alright. Objects, geometry, stuff is everywhere. This time I'm going to do a little bit different. I'm going to do G. So if I have to think about this triangle, and X to Y, I see 2 points, and then I see a line, so I know this is a segment. Y'all tell me what you think E would be. E is also a segment. Alright, I have a point, no arrows, and it stops, so therefore it's a segment. Okay. For A, again, this time I see an arrow at the left and an arrow at the right. Because I see two arrows, that's going to tell me line. So think of this as being line CD. Again, the type of geometric vocabulary word, then the points that it goes with. So how would you call this? This is called ray. Again, array is a little bit different. You're not going to see your beginning point, but you will see at one arrow. So it's going to be ray E F. Okay. Again, not going to waste our time to go through all of these. Page 3, kind of similar to what we just did on page 2. I want to really focus on the bottom, however. Use our imagination to tell if these lines or segments or rays will wind up touching. Again, I'll do 1. I'm going to expect y'all to do 2. And number 1, so like if I look at this, first thing I need to ask myself, can I use my imagination to continue on any further this way or any further this way? And my answer is no, because I have ending points. Okay, I don't have an arrow. So I can't add or take away any more than this. Same thing here. I have a point, no arrow. So what I see is what I got. So these are not going to intersect. All right. And then what do you think about 2? All right. 2 does intersect. Now, why do they intersect? Is it AB that causes them to intersect, or is it CD? It does wind up being ray CD because this arrow extends and goes on, and they would probably cross right there. Alright, so again on page 4, if you need help or you want to use your imagination, you can work on question 3, question 4. Again, if you have questions, email me, let me know. Alright, now, like I said, the meat and potatoes behind Math 2, what we need to learn now. So, this is what, or at the beginning I said this unit should kind of be a grade boosting unit, because there's only a couple of different rules and formulas that I need you to remember. I'm going to get you a 2 today. Tomorrow we'll look at the third one, and that's it for the rest of the unit. Alright, So complementary angles are two angles that add to equal 90 degrees. Okay, so it looks like a right angle when you put them together. I don't care how big or how small, as long as my end picture kind of looks like an L. So for example, if I'm given this and I want to say find its complement, I'm missing this piece right here, so I'm going to try my best to kind of put that together, and then if I slid them together, hopefully I would get that. Again, this is not going to be exact, but it's pretty close. Now, supplementary angles are two angles that add to equal 180 degrees, and it just looks like a line, okay, when you put them together. So I have a very big angle, and now I need the smaller portion of the angle so that when I put this and this together, it's common, okay, its common ray that it's shared by essentially goes away, and then you have two rays that connect, again, just making a line. Now, I don't care how the line looks. I don't care if it's going sideways, up and down, at a diagonal, as long as the end result, after you take away common ray is a straight line, it's supplementary. Same with complementary. All right. So these are some of the questions you're going to be asked. If I give you a angle, find its complement, find its supplement. Okay. So this time I feel like doing number 3, and then I'll let y'all do number 1. So find an angle's complement if I'm given 23. Okay, so I have to think back again. Well, what does complementary mean? Complementary means two things that add to be 90. So x plus 23 equals 90 degrees. All right, how can I get x by itself? Again, this is where once we get here, we can just go to Desmos and stop, right? Because once we set up an equation, really think of it as being just a system. Okay, y'all are in Math 2 now because y'all demonstrated in Math 1 that you could do this by hand, all right? So I go to Desmos, I type y equals x plus 23. I go to Desmos, I type y equals 90. I zoom out until I see where the two graphs intersect. I want that particular x value, and I get 67 degrees. What's the complement of 45 degrees? Again, 45 plus what equals 90? Again, the plus what, think of that as your variable, plus x equals 90. Again, if you can get here, you can go y equals, and then you get 45 because that's the x value. Again, we're solving for x. At what x value can I plug in here that makes 45 plus x equal 90? Again, get here and make a system. Here I'm going to do number 5. Okay, if a pair of supplementary angles is given, what's the measure of the missing angle? All right, keyword here, supplementary. I know supplementary is 180. This is the hardest part of the Dave stuff, is differentiating and remembering that complement means 90, supplement means 180. Okay, so 75 plus what equals 180? Again, the plus what is x, y, z, just pick any variable. And then you have your equation, y equals, make you essentially a system. Go to Desmos, y equals 75 plus x, and then y equals 180. Find the x value where they intersect, and you should get 105 or 105 degrees. Y'all do number 6. All right, number 6, Again, 92 plus what equals 180. Again, the plus what will be x. I have my system. I go y equals. I go y equals. I will then go to Desmos. And again, answer choices on a test are going to be like I'm only going to do 2. So say, somebody says 98. Well, is 98 right? Well, you can always plug it in, right? 92 plus 98, or you could check the math, 10, 18, 19. So that's 10 too much. So like my answer must be below 98. All right. Well, let me try 78. So 92 plus 78 is 10, 16, 170. Well, that's too small, right? So then we kind of do like the Goldilocks effect, multiple choice. We would eventually go to where things were just right. So again, multiple choice, they're going to tell you the answer. You just have to know the definition, how to get to your system, and then get your answer. All right. My answer winds up being C, 88 degrees. Page 6, page 7, way too confusing. All right. So what I want us to do is do page 8. Again, I'm going to do 1, then I'll let y'all do 2 and 3 on your own. Again, if you have questions, email me. So, determine the type of angle shown, and then find the value of the missing angle. Okay, so that's kind of our flow map. When I'm trying to find x, I have to run through a thought process, and that thought process is, this is an angle by itself. Okay, this is angle x, and this angle right here has a measure of 70 degrees. The measure of this angle is x. If I take away their common vertex or their common ray, all right, I'm left with a line. So then I think back to my notes and I say, okay, these are supplementary. As soon as I think supplementary in my mind, I think 180 degrees. Well, so x plus 70 must equal 180. Okay. Now, I get my equation, y equals again, y equals everything on the left. Once you get to the equal sign, you stop, and then you start on the next one. Y equals everything on the right side of the equals 2 sign. You want the x value where they intersect. X winds up being 110 degrees for this particular problem. Alright, so your number 2. First off, are these supplementary angles, complementary angles? They are supplementary because when I cover their common ray, I'm left with a line. Okay, so they're not complementary, they're supplementary. Now, what is your equation going to be? It should be y equals 85 plus x. Your other equation should be 180 degrees. Again, this being because they're supplementary. Again, this plus this equals, or if we were doing it like up here, 85 plus x equals 180, where 85 plus x is there, 180 is there.